Hi everyone, let me welcome you to the 14th session of ECT 204 Signals and Systems. So in this video we will revisit the sampling theorem and we will try to understand more about the signal reconstruction in the light of convolution. The contents of today's session are your learning outcomes, then the sampling theorem, a revisit of the sampling theorem and the summary of understanding. So you will revisit the sampling theorem and understand how the sample signals are reconstructed in the light of convolution. In the first sessions where we discussed the sampling theorem, we said that the signals could be reconstructed with if two samples are taken out of a period, and we saw the interpolation formula. But at that time we didn't discuss convolution, so we couldn't say more about that. This in the light of convolution, we are looking at reconstruction again. Now, the Nyquist sampling theorem, as we said in the previous session, it states that if the highest frequency in a continuous signal xt is fm, and if it is sampled at a rate fs that is greater than or equal to 2fm, then xt can be exactly reconstructed from the samples using the interpolation formula gt equal to sine 2 pi fmt by 2 pi fmt. So this gt is actually an ideal low-pass filter. So what this theorem says is that your samples can be reconstructed if those samples are passed through an ideal low-pass filter. Now let us see what happens when we pass samples through an ideal low-pass filter. Now this ideal low-pass filter, so this is how I reconstruct the signal. These are my samples. These are my sampled signal x NTS. These are passed through an ideal low-pass filter with impulse response sine 2 pi fmt by sine 2 pi fmt. So this basically a sinc function. So the frequency response of this is unity from minus fm to plus fm. So outside it is completely zero. So this is an ideal low pass filter, and at the output you get an approximation or an estimate of xt. Now let us see what happens. Now what happens is when I pass these samples through this filter, this x and ts is convolved with this gt, and let us see how this convolution happens. So the sinc function gets convolved with the samples or impulses when they are passed through the filter. So the sinc function gets convolved with the samples. These samples are basically impulses. So when any signal gt is convolved with an impulse, you get the same signal gt. So what happens is you get a train of sinc pulses. So the reconstructed signal is obtained by detecting the peaks of the train of sinc functions. So this formula is called the Whittaker formula. This is the only function with which you can reconstruct your samples. And now what happens in effect is this picture explains what the exact picture. So this is my sample at n equal to 0. This is x0. This is a sample at n equal to 0. Now what happens is when the sinc pulse is convolved with it, it looks like this. This is my sinc pulse. Okay, when a sinc pulse is convolved with any function is convolved with an impulse, you get the same function. So when the sinc is convolved with this impulse, you get a sinc pulse of height equal to the height of the impulse. So this is how that impulse, and this is the second sample. That is when convolved with the GT, you get this curve. You get this red curve. Okay, and this is the third sample. So that when the third sample is convolved with the GT, you get this this GT with the height equal to the impulse and this blue curve results. You can see that all zero crossings coincide. All zero crossings of the sinc pulses coincide. And if you look at the peak of this one, peak of the sinc pulses, you can see that it's an approximation of your original signal. Okay, this was your original analog signal. If we detect the peaks of these sinc pulses, we can get an approximation of my original continuous time signal, and this is how the reconstruction happens. And the summary of understanding, in this short video, you revisited the sampling theorem and you understood the reconstruction in the light of discrete convolution. So the reconstruction is done by Whittaker interpolation formula, and the reconstruction is done by passing the samples through an ideal low-pass filter. And that is the end of this video. I thank you very much.